right, hello everyone. Welcome to Anonymization in the LLM era, no room for compromise. Our speaker today is Christoph Willensen. So without further ado, I'll hand it off to him.
Thanks, Fana. Happy to be here. Hi, everyone. My name is Christoph. I am CTO at Graphware. So our company helps agencies around the world to leverage connected data to identify, locate, and disrupt criminal activities. In today's session, I want to raise awareness about privacy challenges when using LLMs, especially when you use sensitive data such as people's name, date of birth, etc. I want to highlight the amplitude actually of the problem, especially with recent developments. I will speak about different techniques to help use data securely with LLMs. And so it's not about preventing data to go, it's also continuing to leverage LLMs in a safe way because they are very powerful. All right, so sensitive data leaks are nothing new, really, right? So it happened before LLMs, but of course the LLMs amplify the problem, right? So if you read the news, and especially cybersecurity news, you will see that there are a lot of occasions where sensitive data has been shared or transmitted. And it can be automated, so it doesn't have to be a human originated, but sometimes it can. For example, here where a worker uploaded 3,000 people data to an LLM, right? So the issue is really how the ecosystem evolved since the LLM era. So it all started, with a user being able to use ChatGPT, send a prompt, and get a response. And then it evolves to having microservices that can leverage LLM on behalf of the user. Then came tools that access databases, websites, code that are then embedded in LLM calls. Then we had RAG, like that also access documents mainly that are sent to LLM to ground the answer. To ground the context actually. And grounding the context involves generally private data. This is why RAG was developed, is to be able to leverage LLMs with data that the LLM doesn't know, right? Then we had, let's say, workflow-based systems where it's a combination of all of this that are used with LLMs and private data. And again, the multiple nodes that are doing different tool calls or calling LLMs, etc. Then came agents that have the same access to tools, databases, and are using LLMs. Those agents were maybe developed and controlled by code, but then came autonomous agents where actually the LLM decide what tool to call, what web API to call, what data to retrieve from a RAG-based systems, what other agents to call, etc., etc. Right. So as you can see, the evolution of the ecosystem around LLM has become extremely complex to govern, actually. Right. So, and any security officer that would look at this and wouldn't see any safeguards would probably not be that much amused about this complexity and this new ecosystem, right? So what we will start now is seeing how we can go from cool demos. I'm sure you have seen very, very cool demos during the Notes conference, and how to go from that into a production-based system, or let's say a safe-based system, right? So because this is the reality, really, right? So So I will take an example document. So the data on the document is actually fake, right? So we have replaced every sensitive information that was in the original document. However, I want that you look very closely to the document because um, this document will provide a surprise at the end of this talk, actually. All right, so this is a charge release report, so a person that has been arrested and for a specific offense. So the first part probably is where you will want to identify mentions of entities that are considered sensitive, like what is typically called PII data. Um, so we can start with the name of the offender, maybe his age, can also be date of birth, etc. Right. So in typical system, you will generally have to identify the type of entities that you're interested and consider sensitive, right? So there has been like long-lasting approaches, especially in traditional machine learning systems with rule-based extraction, machine learning-based extraction, such as BERT. There is a nice library from Microsoft called Presidio that is for redacting data from text. There is also Filter that is a popular library for reduction. Um, but there has been, of course, a lot of pros and cons that have been there for like probably more than a decade now, right? So the pro of it is that it's very, very fast, right? So once you have a system running, identifying PII entities in text takes really no time, right? So it's super fast and it's super cheap compared to LLMs, right? So um, the cons is that only non-entity types can be extracted. So typical libraries will provide common entity type support, such as person and organization address, um, maybe colors and things like this. But when you work in specific domains, for example, law enforcement, where you will need to identify license plates that are specific to maybe a state, to your country, you will need to identify specific officer badge numbers, for example, that have also um, a specific pattern. So adding support for those entity types is generally expensive. Not expensive in terms of infrastructure cost, but expensive in terms of training and development cost, right? So it's not easy task and it's expensive. Now, recently there was an article that say that LLMs are the best entity extraction software. Right. So the reality is that it's not really true. So you will have to do this on premise because if you want to redact data, you cannot just send your data to a cloud-based LLM such as OpenAI to extract entities. Right. So running an LLM locally has cost and is not so efficient and also accurate. Right. So one of the pros is that it can generalize kind of okay. So by prompt engineering, you will be able to identify new type of entities in, let's say, in a very fast way. You will have okay results, but going from okay results to accurate to efficient results and something that can work on a large amount of text, this is where the reality will show you that it's not so easy to use LLM, even locally and even small language models. It is not so easy. So the con is that it's slow as well, right? So running an LLM compared to a machine learning model is like order of magnitude slower, right? So we're speaking 2,000 times or even more slower than using a machine learning based model. It is not cheap, so it has infrastructure costs, and it is not so easy. Um, However, we did some tests, of course. So what we identified is that models with reasoning will take generally the longest time for no benefit. So we also found that reasoning in general, models with reasoning capabilities, will add more confusion for the extraction than something else, right? So then you can have non-deterministic results. So And interestingly, it's happening more and more than what we thought would happen, right? So a small language model fine-tuning could potentially be a go-to alternative, but for our side, it's a bit early to say because it requires kind of some amount of data, but also some amount of validation from human, right? So regarding the extraction from LLM based systems, what I can say is that we had the best outcomes when using Mistral Nemo for entity extraction. Now it was for all tasks, for all types of documents. We are not recommending this in any way. It's just a FYI from our experience with attempting to do entity extraction with LLM models. The next step will be to replace the entities with alternative text before sending it to the LLM, right? So here it's very important that that the replacement is done in a way that will be useful for the LLM as well. Right, so I will share here what you don't have to do. So first is replacing with fake names. For example, using a faker library that would replace the name will not be very useful for LLM. For actually, it would not be very useful for yourself after the LLM task, right? So if you do tasks such as summarization, LLMs will tend to uh, replace the names with just the last name, for example. So you can see in the example, Marcus Delaney was replaced later with just Delaney. There will also be just Doctor something if you have the full name before, etc. So it's problematic for you after for re-identifying the entities in the text, right? So don't do that. What you shouldn't do as well is use hashes and cryptographic values, right? So LLMs are very good at understanding things. So if you pass hashes or crypto values, you will break sentence structures, and that will confuse the LLM models. Non-ASCII symbols also reduce model accuracy, and more importantly, you can see that if you have a lot of equals character or that are ending the values, the LLMs can actually produce a new token that will be just a partial value of the hash, for example. And then it can't infer what he should be able to infer. So if you remove context from the text, he will not be able to do his task efficiently, right? So LLMs are good at identifying roles and relationships between entities and take advantage of the context to perform correctly a task, right? So don't do that. So what you should do is to use structured placeholders. So for example, a person A97 included in square brackets. Because it is one token, there is no risk that the LLM will split the token in multiple tokens, and it will be easy to re-identify the data later, right? So you can see how that text would look like after replacement. So you would replace every occurrence of the name by a reference with a placeholder. Then the next task is to send that data to the AI, and let's say that he will summarize the text, and then you will store the results in a database or as a PDF file and send it to somebody, etc. Right. So this is what would be a cool demo actually. However, you shouldn't do this, right? So data that has been generated by the LLM in production systems should be treated as properly as any of the data, actually, right? So it is even more important that you know, for example, the entities, and you have more information about the entities that were part of a generative text that can be used in our field, for example, for investigation or later for prosecution, which is even more problematic. Right, so that type of system wouldn't fly in a typical governance framework for AI usage. So, and the reason why is that generally the entities that you extract from text have meaning across your source systems. So here we can, like we will try to maximize the times where data extracted from text would actually match data that is already in our graph. Especially, we would have information about persons and vehicles, etc. So we want to first identify to what entity in the graph, actually source of truth, that that text entity can refer to, right? So that would, of course, incur entity resolution work to do, but you will want to maximize this as well to have better quality data from your generative AI task. Um, the reason you cannot do the approachable is that because it relates to information that is governed also by law, like not everybody should see every person you have in your graph, right? So sometimes it depends based on investigation. It can depend based on source system that you have access to or not. So a user on the left can have access to the data, but not on the user on the right. So that means that should reflect as well in generative AI production of text, right? So what would be an ideal system to make this safe enough to continue forward, right? So one, you have to keep track of the replacements, keep track of the identity, the entity identified, sorry, the replacements used, and the entity to which it refers to in the graph, right? So once you have those three elements of information, you can generate a kind of object, let's say, that you would store in a secure system. So very important when you have mappings between original text and what was the placeholder used, etc. You need to store this as securely as you would store any other data, right? So, and ideally, it should even be on a separate system so that you would avoid escalation of access if you're getting intruded by hackers, etc. So once it is stored in the database, you get a reference, like a kind of token that you can use to put in your text after the task is performed by the LLM. So instead of keeping the replaced value, you just store that kind of reference to the object in the database. And what are the advantages of this? Is that, sorry, when you need to read the text, you have to do the opposite. You read the text, you get the token from the text, you exchange the token for an object coming from the database, and then you identify the user requesting access to this object, right? And the advantage of this is that now you have a framework where you can choose and make decisions about what to do with that information. So if the user doesn't have access at all to any of the entities in the text, you can throw an error. You can keep the identity mask, for example, even replace with just triple X or whatever. You can, of course, return the real value of the entity that was in the text. And more importantly, all this, let's say, controlled way of returning generated text with PII entities, it is very easy to plug into and have other systems, for example, deciding, okay, we have this person that is maybe a politician. We need to know in which generated text he is mentioned. Also, for some compliance reason, you might have to delete data that was referred to a certain person. So you can easily identify and make this work here by just using those tokens. It's more structured information about entities that have been um, replaced from original text. All right, so that was about a simple entity such as name. Now you can say, yeah, but what about dates and times and addresses and such additional information like even vehicles? etc. And that is very interesting because this is the other side of the coin of the compromise, is that we also don't want to compromise the LLM capabilities. So LLMs are very, very good at reasoning um, on people, place, events. They have temporal understanding. They have spatial awareness. They can generalize pretty well. So we don't want to waste that. We really want to leverage the capabilities of AI actually, because criminals are actually probably way upfront than typical government agencies that would try to disrupt them. So, um, and if you have seen recently, um, in the last 2, 3 months, let's say that context engineering has been a very, very hot topic. So that means that taking care about using the context correctly um, is of high importance to leverage LLMs to their maximum, right? So, and if you attended my colleague Dr. Alessandro Negro sessions this morning, you will see that he was using like a multi-agent framework that could do demographic analysis, temporal pattern analysis, and geographic intelligence analysis. But that could work only if how you redact the data keeps that awareness and context into their replaced value, right? So that don't do here is naive reduction, right? So you don't want to just replace times with fake time, or it has to remain contextually aware of the original document. So what you should do instead is use context-aware placeholders, where, for example, for dates, you would use a time window placeholder, such as early in the morning or late evening or evening 20 underscore 24, for example. For addresses, you would want to generalize to neighborhoods or grid level. So, for example, block 400, especially in America, it's very easy to use grid level because a lot of cities use grid level for their streets. Um, time of certain sequence. So we need to keep temporal reasoning. For example, if like earlier this day or 15 minutes before the witness saw a person leaving, for example, you need to keep that temporal reasoning into the replaced value. Vehicles, you need to drop specific, but you need to keep class and maybe color. For example, dark sedan, even color you can generalize to higher domain level of colors. So and yeah, so this is how a text would look like after such replacement. And you need to try as much as keeping the context without compromising on the safety of the entities, right? So, and also why we want to replace temporal, like time based, and address is more obvious, like for example times, etc. Well, like there have been a lot of anonymized data sets that have been released in the wild, like on platforms such as Kaggle, etc. The reality is that anonymization is very, very, very hard to ensure, right? There has been a lot of studies and a lot of issues with anonymized data set, like Strava and the New York cab drivers data challenge on Kaggle. People were able actually to re-identify the data based on other factors like times and locations, etc. Right. So it's not only names, it's not only IDs. It really the whole context around a event can lead to re-identification if not properly handled. Right. So um, thinking you're safe, well, it's not really true. Um, and I want to. So I say that my last slide would be related to the first one where I showed the charge release. Well, the reality, as we say, that thinking you're safe is not really true. So you can end up with this session thinking that we have actually uh, replaced and even masked all the PII and the sensitive information that was existing in the text. And it is true, the entities themselves, like in the text, have been replaced. And if you would type the name of the person on Google, or you would ask ChatGPT research to search everything about this person, there would be no information to know about this person. But one thing we didn't focus on, and I think everybody missed probably, is we didn't focus on the title of the text. And if you look here, just by removing Lakeview from the title, if you would use Google, and if you would use ChatGPT research, for example, who can use Google, well, you can actually link back to the original charge release reports. You will have the picture of the person, you will have the real name of the person, the real details about the arrest, etc. So even if we did our maximum to safely tr- safely replace sensitive data with placeholders, while we didn't focus sometimes on the non-obvious portion of documents, pieces of data that can also lead to re-identification and thus be considered a data leak to some aspect. So as a conclusion, I want to say that yes, history keeps repeating itself, and it will repeat itself again and again. So there is no way around it, and that's just the reality. So LLM ecosystems really multiply the exposure now of data leaks. Um, Context matters, so you don't want to also prevent using the capabilities of the LLMs. Um, Naive reduction fails in general, but I think it's just um, real engineering at the end of the day. So structured and context-aware placeholders will win in that case. Human oversight remains crucial, of course, even if it will get harder and harder to validate all the data. It is even already impossible, but human oversight remains. And yeah, no room for compromise, right? So you want to make your data safe, and you want to use novel technologies to catch more criminals. But the reality is that um, there should be no compromise, right? So to the safety of your systems. And on that note, I want to thank everybody. So as I said, I'm Christoph Williamson, CTO at Graph4ed, and I also co-authored Neo4j, the definitive guide, who is released already since a month or two. And thank you. I don't know if we have time for questions. We should. Are there any questions? There aren't. All right.